Next, we have a special example. Now, the other day I happened to be in a drugstore where I happened to notice a couple of boxes of allergy medication. Now, the two boxes were for different types of relief, different periods of time, and they kind of advertised themselves as follows. So the first box said 12-hour relief. So take your pill twice a day, and it was a 60 milligram dose. So 60 milligrams every 12 hours. Second box was 24-hour relief, and it was 180 milligram dose. So take it once a day, but take 180 milligrams once a day. Other box, take it twice a day, but take only 60 milligrams per day. So the problem I'm going to ask right now is to figure out what the continuous decay rate is. So when we have, e to the minus kt, and we have the initial amount present. So if you take a tablet, you have so many milligrams present in your body initially. We'll assume that the amount present decays exponentially, and so figure out what the exponential decay rate is. So we need an assumption to solve this problem. So our assumption is that under both scenarios, the same amount of drug is left over at the end of the period. So basically when you have to take your next dose. It's left over at the moment you must take the next dose. So in other words, you start off with 60 milligrams. Whatever is left in your system after 12 hours, that's the point when you need to take the next pill. And whatever's left in your body after 12 hours is the same amount that's left in your body if you take a 180 milligram pill that will be left after 24 hours. So basically, if you take 60 milligrams and you have a decay rate of K, so much is left over after 12 hours. If you took 180 milligrams, it would take 24 hours for the same exact amount to be left over at the end. So in other words, there's a certain amount that once you drop below that amount present in your body, it's not effective anymore and you should take the next pill. So the assumption is that they've calibrated the doses correctly so that there's the exact same amount at the end of both periods. So if you start off with 60 milligrams, it takes 12 hours to reach a certain amount. Whereas if you take 180 milligrams, it takes 24 hours to get to that same amount left. So basically the amount, we'll call it Q of t, is equal to the initial amount, then e to the minus kt. So two scenarios, we have 60 milligrams and we have 180 milligrams. So using this scenario, we have, let's say Q1 of t is equal to the initial amount 60 and then e to the minus kt, whereas in this scenario we have Q2 of t is equal to 180 e to the minus kt. And we'll assume that the decay rate's the same for both cases, right? So it just depends on the absorption rate of your body or something like this. And then the assumption is that, well, Q1 after 12 hours is equal to Q2 after 24 hours. So however much is left after 12 hours of taking the 60 milligram dose, it's the same amount left over after 24 hours of taking the 180 milligram dose. Okay, so let's use this assumption to figure out what the decay rate is. Okay, well, Q1 of 12 is going to be 60 e to the minus 12k, whereas Q2 of 24 is 180 e to the minus 24k. Let's divide by 60, and we get e to the minus 12k is equal to 3 e to the minus 24k. So now let's multiply by e to the 24k. Well, e to the 24k times e to the minus 12k is just e to the 12k, right? Because you do the 24 minus the 12 and you get 12. And then e to the plus 24k times e to the minus 24k, those are reciprocals, so you just get 1. And of course the 3 is still out here like this. So e to the 12k is equal to 3. And therefore 12k is equal to the ln of 3. Therefore k is equal to 1 over 12 times the ln of 3, just like this. Now let's find out, well, how much is left over in your body after those 12 hours or the 24 hours. Whenever you have to take the next pill, how much is left? So what's that minimal amount where if you have less than this amount, you should take your next pill? Well, let's plug this value for k into our equation and then see how much drug will be remaining in our system after 24 hours. So k is ln of 3 over 12. So I have that right here, just ln of 3 over 12. Make it negative, multiply it by 12. That's negative k times 12 hours. Take the exponential of that, and we get 1/3. So it's 1/3 times 60. So basically, Q1 of 12 is going to equal 20 milligrams left over. So after 12 hours, there should be 20 milligrams present in your body if you start off with a 60 milligram dose. Then similarly, if you start off with 180 milligrams, you can check this yourself. You use this formula, use this value of k and use t is equal to 24. You'll see that Q2 of 24 is also equal to 20 milligrams. So either way, after the period of time is over, there's 20 milligrams left and you should take your next dose.